Okay, so there are a couple of ways that if you have a tracing of a circle to find the center of a circle. Okay, one way that we did was I found where I think a diameter is, like here. I made 2 marks on the paper, and then I folded the paper so those 2 marks line up, and then the fold is at the radius. Then I go that far below the diameter, and I got a little line segment here and a little tick mark here that showed me where I thought the center was. Okay, but then I measured it in this direction, and I found that I was about 1/8 of an inch to the left of the center, so I moved to the right. Then I made the mark, but the chalk didn't mark where I thought it was going to, so the mark came out a little low. Okay, that would have gotten me a pretty good estimate of the center. Okay, can you mathematically prove that so? And, you know, could you mathematically prove if you do this, check it, do it again, check it, and modify it, how quickly your accuracy improves? Of course, you're limited by your ability to see what you're looking at, right? After a couple of steps, your errors are going to get so small you can't even really see it. Okay? That's like 3 steps if you do it carefully. Okay, another method, a geometric construction is take a chord, find the midpoint of the chord, take a chord, find the midpoint of the chord. Now, I just estimated those midpoints. And you could make a couple of marks, fold your paper and stuff. You should be able to do this with compass and straight edge, but people aren't doing compass and straight edge constructions. Ever do a compass and straight edge construction?
Like twice.
People were afraid you'd stab each other. They didn't give you anything sharp. And they, you know, with some of the people in your class, maybe some of you, there's reasonable fear. Okay? That there'd be bloodshed, even death. Okay? Well, hopefully not. Okay, well, there are reasons for these things, but it's really kind of sad that people aren't doing those constructions because they so inform your understanding of geometry. And there are whole branches of mathematics that are based on what you can construct. And you get very important insights. So I'd recommend you learn to do basic geometric constructions. Like, can you construct a chord? Well, that's pretty easy. Just take 2 points and draw a straight line, right? Can you bisect a straight line with compass and straight edge? Very fundamental, very simple. Okay? So if you've done it, you would know. Probably. Okay? So can you construct the perpendicular bisector of this thing? Well, yeah, if you bisect it, you can construct a perpendicular bisector. I'm not going to go through how. I'm just going to ballpark it because that's all we really want to do. We're trying to construct a circle to get some good idea where the center is. So I'm thinking that it's along this line, and I wasn't cheating. And you know I wasn't cheating because I didn't hit the exact point because this point's too low, but I hit it. Anyway, okay? And then I join that up with the perpendicular bisector here. It's pretty darn close to what I got the other way, right?
Mm-hmm.
Of course, again, this point is a little too low. The actual point where these 2 lines cross is a little bit to the left of that and a little bit higher than the center of the little mark I made. So we're going to take that as the official center. So there it is. Now that's a better center than the one I estimated here on a slightly more lopsided circle, which I drew freehand, looking at it from this angle where it looked pretty good until I stepped back. Okay? And then I set up my axes and I missed the stupid center. I wasn't paying attention. Okay? If you look at the center, you're probably going to hit it. Anyhow, here's my picture. So now I've got an x-axis and a y-axis. And my unit circle, the most basic unit circle is a circle like this of radius 1. Okay? Centered at the origin. Okay? Now, the thing I have you do in an exercise that was there in your first day assignment, so I'll refer you back to it, we haven't done it. So, okay, start from the center and bisect this arc, which of course you can do with compass and straight edge. Okay? Now, that was a little high, but you get the idea, right?
Mm-hmm.
Then bisect it again. Or bisect each of these arcs, right? Then bisect again. Okay, well, you understand what I'm doing. You don't have to use compass and straight edge. You can eyeball it. Okay? Now, we want to write down our estimated coordinates . Now, there are two coordinates that we know, right? What are the coordinates at this point?
That's
1,
1,
0.
0.
Clearly, that's 1, 0. If this thing has radius 1 center at the origin, then you're at 1, 0, and I'm sure everybody completely understands why. And up here, we're at 0, 1, right?
Mm-hmm.
Okay? Now, can you estimate the coordinates of all these points?
Yeah.
Yeah, I mean, you want this one. You just project over and down, and you get estimates. Of course, you can bisect or whatever. You mark it into 10 units along here, 10 units along here. But it looks to me like this is at least 0.9. So I'm going to say, this point is probably 0.9, 0.3. It's possible that point's on the unit circle?
Yeah, maybe, yeah.
I'm sorry?
Yes.
Well, no, because I'm using an estimate, and it's, the coordinates of this point, wherever it happens to be, are probably irrational numbers that I can't estimate with that much accuracy. Is that a reasonable estimate?
Yeah.
Well, Pythagorean theorem says that this squared plus this squared should equal this squared, right?
That is.
And this distance is 1. Well, 0.9 squared is 0.81, 0.3 squared is 0.09, that gives you 0.9, right?
Yeah.
Square root of that's about 0.95, which is pretty close to 1, so it's not a terrible estimate. If I change this to 0.4, it'd be too big, right? It doesn't look like 0.4, so we're just going to stick with 0.3 and say, yeah, that was an okay estimate, right? So we just kind of estimate these coordinates around the circle, right? So I'm just going to say, okay. Let's say my x coordinates are let's just say 1, 0.97, 0.9. What's that look like? That's 0.9, that's probably 0.8. And this is probably 0.7. That is getting down pretty close to half. I'm going to say that's maybe 0.55. And then here looks like about, I'm thinking about 0.4. This one looks like about 0.2 and 0. Now, you don't have to copy those because I want you to make your own estimates. Okay? Now, if these are at equal angles, well, how about we do this not with angles, but with the distance along the arc? Okay?
Mm-hmm.
How far is it from here to here if we go along the arc of this circle?
From where?
From this point to this point. The entire arc in the first quadrant.
Oh,